All right, guys, we're going to start a new lesson. It's just a really quick one. We're talking about L'Hopital's rule. Okay. This is actually a BC topic, but next year it's going to be included in the curriculum for AB. So this is a great way of evaluating a limit when you get an indeterminate form. Now, earlier in the year, we talked about situations where if we put in the value, we actually get either 0 over 0, and every time we talked about 0 over 0, we said do something algebra. Well, there's actually another way that we can do, because with this type of problem, you can't do something algebra. But with problems that we've dealt with earlier in the year, you could do some factoring, you could do some canceling out, and then you could just evaluate the limit. An easier way to do this is L'Hopital's rule. Now, L'Hopital's rule deals with taking the derivative, and that's why we haven't learned it until now, because we didn't know how to take a derivative. So, really useful thing. This happens anytime, like I said, you have an indeterminate form. And indeterminate forms are when you have 0 over 0, or we're also going to talk about infinity over infinity. These are the only two we're going to work with. There's actually many more that you'll learn in BC, but for this purpose, the only thing that you're going to really need on the exam is 0 over 0 and infinity over infinity. All right, so you're getting to the exam and you see a limit, and you've all gotten really good at limits. Well, in this case, you plug in 0, and we find out we get e to the 0 power, which is 1. 1 minus 1 is 0. 0 over 0 gives us our indeterminate form. All you have to do for L'Hopital's rule is take the derivative of the top and the bottom. So what we're going to do is take the derivative of the top, which ends up giving us e to the x, and on the bottom, which would just give us 1. Now we can actually substitute directly in, put the 0 in, e to the 0 gives us 1. That's all it is for L'Hopital's rule. You take the derivative of the top and the bottom, and then evaluate the limit like you normally would by direct substitution. Okay? So, if you get to a point where you still have 0 over 0, or infinity over infinity, you just keep taking the derivative again and again, until you get to a point where you can plug directly in. All right, let's take a look at this one. If we put infinity in here, all right, natural log of infinity goes to infinity. So this is going to be infinity over infinity. This is our second indeterminate form. So what we're going to do now, same idea. Take the derivative of the top, 1 over x over 1. And now that we've taken the derivative of the top and the bottom, now we're left with just limit as x goes to infinity of 1 over x. Now we can actually go directly into it. And what do we say when we have 1 over a really, really big number? It approaches 0. Okay? Like I said, these are just two examples of when we have those indeterminate forms. Let's take a look at another one. Right. Limit as x approaches, let's do 2, where we have x cubed minus 8 over x minus 2. The dreaded sum of cubes and difference of cubes, SOAP factoring. Some of you may not remember how to factor with SOAP on the AP exam, but here's the nice thing. We put 0 in here, or we put 2 in here, we get 0 over 0. Hey, 0 over 0, since we're dealing with a limit, we can go ahead and use L'Hopital's rule. All we're going to do, again, take the derivative of the top, derivative of the bottom. Derivative of the top is going to be 3x squared. Derivative of the bottom is just going to be 1. Hey, now I don't have an issue anymore. Let's go ahead and plug it in. Put in 2. 3 times 2 squared gives us 12. That would have worked the same if we did our sum of cubes. Let's check it out. We always learn do something algebra. This factors to x minus 2, x squared plus 2x plus 4, or x minus 2's cancel out. Now we can use direct substitution. So let's plug it in. 2 squared plus 2 times 2 plus 4 gives us 12. Same answer that we got with L'Hopital's rule. Much easier, much quicker. Okay? So L'Hopital's rule, tonight you're going to have some homework with just practice of this. Anytime you have a limit, all right, where you have 0 over 0 when you do direct substitution, or infinity over infinity, you can use L'Hopital's rule. Take the derivative of the top, derivative of the bottom, and once you get it so that you can plug in, all you gotta do is plug it in and get your answer. Okay? Very easy topic. Again, could really help you out on the AP exam. Okay? That's all for that one.